All right, so sometimes when you're looking for the solution to quadratic equations, you can't use factoring for some reason. It doesn't factor well. The square root property doesn't work because you have a linear term, and you're left hanging out there in the dust. You have no idea what to do. Luckily, we have a powerful, powerful tool called the quadratic formula. Now, you know me. I never make you memorize something that you don't need to memorize. Quadratic formula, you need to memorize. So whatever it takes, just start doing it now, figure it out. The quadratic formula gives you solutions. Your solution x is equal to the opposite of b plus or minus, plus or minus looks good because we're expecting, remember, two solutions in a quadratic equation, minus b plus or minus the square root of b squared minus 4ac all over 2a. You have to memorize that. Now you have a little bit of a cheater if you're in my room, because remember the mural on my wall actually has it in there. That doesn't give you permission to not memorize it. It just means that you're lucky in my room. But the quadratic formula is something you just need to know, and you need to know it forever. So start memorizing now. X equals minus b, or the opposite of b, plus or minus the square root of the quantity b squared minus 4ac over 2a. Now, what are b, a, and c? What are those? Well, they come from the standard form of a quadratic equation. Ax squared plus bx plus c equals 0. Even though in standard form, or when we write the equation, we use capital letters, and in the quadratic formula, it's just we tend to use lowercase letters. It doesn't mean we're not talking about exactly the same thing. It just means that A is A, B is B, and C is C. Okay, so in the equation we use capitals, in the formula we use lowercase. They're exactly the same values anyway. So let's go ahead and do look at an example, and there's a little bit of teachy stuff that I have to give you in the example, but I think if we go ahead and start working, you'll see that it's really pretty easy. Quadratic formula method for solving quadratic equations is pluggy-chuggy math. You plug in values, you chug away. And I don't know about you, but that's my favorite kind of math. So we're going to solve x squared minus 8x plus 16 equals 0. So this could be solved by factoring, and I'm going to go ahead and do that just because I think it's a good example. So we have x minus 4 times x minus 4 equals 0. That means x minus 4 equals 0 using zero product property. X equals 4, or x minus 4 equals 0. Well, duh, that's exactly the same thing. X equals 4. So the solution to this is that x equals 4, the solution to this quadratic equation. Notice I only got one solution. Remember, you can have as many as 2 solutions in a quadratic equation. You don't have to have 2. You could have only 1, or you could have none. But in this case, I only have 1, and that's certainly okay. And because I found both factors, I know that I found all the solutions. Just because there could be a second one, it's clear that there's not. The 2 factors, which would lead normally to 2 solutions, end up only leading to 1 solution. And so I know I'm done. I don't have to look for any more. Let's do the same one as a quadratic formula. So I'm going to write it all over again. X squared minus 8x plus 16 equals 0. So the first thing I want to do is I want to do my substitutions. And I actually like when you write let. We're going to let a equal 1, b equal negative 8, and c equal 16. We're just taking the a, b, and c out of the equation. A equals 1, b equals negative 8, and c equals 16. Now I'm going to write, therefore, x equals the opposite of b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 16. Now, over 2 times a, which is 1. So all I've done is plug everything into the equation, and now I want to chug away. But I have a little bit of a lesson to give you. This, if you end up with something inside of here that's undefined, meaning if the number underneath is negative, remember, you can't take the negative of some number n. That does not exist in our real world. So you always want to start the quadratic formula inside figuring out whether this is a negative number or not. And BTW, this thing inside, this b squared minus 4 times a times c, this is called the discriminant. The discriminant. And the discriminant has other uses in algebra that you'll use later for other things. But in this case, we want to just use the discriminant. We want to learn the name and we want to know what it is. And we want to go ahead and solve the discriminant first when we're solving the quadratic formula. So for this example, the discriminant then is 64. B squared is 64 minus 4 times 1 times 16 is just 4 times 16. 64 minus 64. The discriminant equals 0. We're always allowed to take the square root of 0. So we're totally fine finishing our quadratic formula. So 8 plus or minus the square root of 0 over 2 equals 8. Well, square root of 0 equals 0, so I'm not worried about that, over 2, which equals 8 divided by 2. Excuse me. Oh, yeah, no, I'm good to go. 8 divided by 2 is 4. Here's why I said excuse me. For a minute, I thought I should have gotten 2 answers, but the plus or minus is connected to the 0, not to the 8, and so I'm only going to get one answer in this case, and that's exactly what happened up here. I got one solution, and I got one solution, so x equals 4 is the solution. Let's do another one and I'll talk about the discriminant again, showing you how I want you to work. So this time we want to solve 2x squared plus 7x equals 9. So just like solving with the square root property, I have to get my polynomial equals 0. So the first step when you're solving is always you get your polynomial number equal to 0. That means I have to switch the 9 to the left-hand side. That's just a simple process. X squared plus 7x minus 9 equals 0. And now I'm ready to work. If I wanted to factor it, I'm in position to factor it. If I wanted to use square root property, I would look and evaluate and see that I have a linear term, so the square root property wouldn't work. And so I'm going to use the quadratic formula. So the quadratic formula is let a equal 2, b equal 7, and c equal negative 9. I'm going to write the formula out. X equals, I'm going to write the whole formula out, even though I may get no solution using the discriminant. But x equals the opposite of b plus or minus the square root of b squared minus 4 times a, which is 2, times c, which is negative 9. All over 2 times a, which is 2. Now, before I work, and this is kind of how I like you to work, I want you to calculate the discriminant first. So you could say 7 squared is 49 minus 4 times 2 is 8 times 9 is 72, but 72 is negative. And so this is 49 plus 72, which is 121. It's a positive number, so I'm not worried about a solution that's negative, right? I don't have this issue. It's a positive number, so I'm good to go. Now I'm going to plug it in. X equals negative 7 plus or minus the square root of 121 over 4. Please don't skip steps. I want you to write this step out, at least in the beginning while you're learning how to do this. And so x equals negative 7 plus or minus, well, the square root of 121 is 11 over 4. And now we've reached a point where we have to chicken feed, right? We have to separate it into our two choices. So I have negative 7 plus 11 over 4. X equals that. And x equals negative 7 minus 11 over 4. So negative 7 plus 11 is 4 over 4, which equals 1. And negative 7 minus 11 is negative 18 over 4, which can reduce to negative 9 halves. So my two answers are the set 1 and negative 9 halves. Whoops. Okay. So as you can see, solving a quadratic equation using the quadratic formula is really just pluggy-chuggy math. You plug in your values and you just do the operations, follow the algebra you already know until you get there. But I told you we were going to come back and talk about the discriminant. The discriminant has some important information for us. It tells us, so I've talked a few times about the fact that if you have a quadratic equation, you can have 0, 1, or 2 solutions. In this case, it was easy to see when we only got one that we had all of the solutions because I had 2 factors. Both factors led to this. The problem is that's not always as easy or obvious as it seems, but the discriminant will actually tell us exactly how many solutions we're looking for. So if you only have one, you can use the discriminant to discover if you found the entire solution. So let's look at this first one. The discriminant in this case turned out to be 0. So the discriminant here was 0, which led to me trying to find the square root of 0, which actually canceled out the plus or minus part. So it's logical that if the discriminant equals 0, there's exactly one solution. Down here, notice the discriminant was a positive number. This discriminant was greater than 0, 121, so it's a positive number, right? Positive. I'm going to just write a positive. Oh, maybe I'll write that with a plus sign. A positive square root. If I have a positive square root, that means I'm going to get a value out of that, and the plus or minus is into play, and so I got 2 solutions for that. So if there's a positive square root, there's going to be 2 solutions, and that's exactly what I got here. If, on the other hand, the discriminant, a squared, whoop, that's not what the discriminant is, leading you astray, b squared minus 4 times a times c. If the discriminant is less than 0, which means that I have a negative square root, we know that we can't take the square root of a negative number. That's impossible, so there's no solution. So there'd be 0 solutions. Let me make a table for that. For the discriminant, if you calculate it, if the discriminant equals 0, there's exactly one solution. If the discriminant is less than 0, meaning a positive number, let's write this. If the discriminant is less than 0, meaning a negative number, that leads to the square root of a negative number. There's no solution. This one leads to the square root of 0. And if the discriminant is greater than 0, meaning that you take the square root of some positive number, which is totally legal, then there are 2 solutions. So for this reason, 1, because you want to know how many you're looking for, and 2, because you don't want to have to do all of this work inside of writing all this extra work, I want you to take the discriminant to the side, calculate it, decide what you're going to end up with, and then plug it back in and finish your work. So let's put it all together, I think, in one more example. 10 equals x squared minus 5x. Okay, first thing, all quadratics, when you want to solve them, you have to get the polynomial equal to 0. That means I'm going to subtract 10 from both sides. So I get x squared minus 5x minus 10 equals 0. This looks like an easy one to factor. If I were solving this, I might be likely to factor this if possible. It may or may not actually factor, but I'm going to use this using the quadratic formula anyway. So we're going to let A equal 1, B equal -5, C equal -10. So X equals the opposite of B, plus or minus the square root of B squared minus 4 times 1 times -10, all over 2A. Oh, not A. Well, it is A, but we have a value for A. 2 times 1. First thing I'm going to do is the discriminant. 25 minus 4 times 1 is 4 times -10 is -40. So 25 minus -40 is plus 40, which equals 65. And at this stage of the game, I want you to say discriminant is greater than 0, therefore 2 solutions. I want you to write that down. I want you to calculate the discriminant, and then I want you to evaluate what it means. Then you can plug it back in. Since there are 2 solutions, let's go find them. 5 plus or minus the square root of 65 over 2. So X equals 5 plus or minus, I'm going to put this one in the calculator because I got the square root of 65 is kind of ugly. So let's see, 65 square root, that is ugly, 8.06 over 2. And now we have to break it into the 2 possible solutions. So we have 5 plus 8.06 divided by 2. So X could equal that, and X can equal 5 minus 8.06 over 2. In the first case, 8, 9, 10, 11, 12, 13.06 divided by 2, and X equals 5. Take away, that's -3.06 divided by 2. Again, the calculator. 13.06 divided by 2, 6.53, and .06, I'm not going to put the negative in because I can do that in my head, divided by 2 is 1.53. So 1.53, and it's negative. So my solution set, meaning all of the answers or all of the solutions to this formula or to this equation, is 6.53 and -1.53.